Hi folks, we're going to take a look at page 403, number 11. Okay, so here they tell us that a telephone pole is supported by an 18-meter wire that makes an angle of 50 degrees with the horizontal ground, and then a 14-meter wire is fastened to the other side. Okay, so let's start by drawing a diagram here. So say here's the ground, I've got my pole. Okay, so on one end it's attached at 50 degrees. Okay, and they give me the length, which is 18 meters. Okay, now there's another one on the other side, which is 14 meters. So I'm going to draw it so that it definitely looks shorter than the other one here. So this is 14 meters. And what they want to know is what angle the second wire makes with the ground. So I'll call this theta here. So right off the bat, seeing that the second wire is shorter, it makes sense that this angle should be should be larger than 50 degrees. So if I get an answer that's not larger than 50 degrees, that probably indicates that I've made a mistake. All right. So let's see how we can solve this here. So we've got two side lengths and an angle. So we've got 3 pieces of information, which is the minimum that we have. And in order to use a sine law, what you need is an angle and opposite side pair, which I have. Okay, and so here to find this angle, well, I have its opposite side. So I have enough information to use a sine law. So that's what I'll do here. And I'll use the version with the angle on top. So we have sine of theta over its opposite side, which is 18, equals sine of 50 over its opposite side, which is 14. And now we can just solve for theta. Eventually, I'm going to do this in one step. I'll still do this in 2 steps here. So let's start by isolating sine theta. So I'll just multiply both sides by 18. So we have 18 times sine 50 over 14, and then theta, the opposite operation to taking the sine of an angle, is inverse sine. Okay. Now, eventually, I'm going to start going from this step directly to that step. So I'm going to do this. I'm going to see that I can multiply by 18 and take inverse sine and do that all in one step. Sorry about that. So let's calculate this here. Okay, so here we have sine inverse of, what do we have, 18 times sine 50, close the bracket, divided by 14, close that other bracket, and we've got, well, we'll just make it an even 80 degrees, okay? So theta is equal to 80 degrees. All right, so that's the first part of the problem. Second part of the problem is how tall is the pole? Now you'll notice here that the pole, because we assume the pole is going to be at a 90-degree angle to the ground, okay, actually forms 2 right-angle triangles. So I don't need to use the sine law here. I can use one of my primary trig ratios. So I could use either one of these triangles because I have an angle in both, now that I know theta, and I have a side length in both. However, I'm going to use the left-hand one because I'd much rather use exact answers than this here, which was approximated. So for B, I'll use the left-hand triangle. We'll call this H. And since I'm looking for the opposite side and I know the hypotenuse side, I'm going to use sine. So sine of 50 degrees is equal to H over 18. And so H is just equal to 18 sine 50. And that's equal to, okay, 18 times sine of 50 gives me 13.79. We'll say 13.8. meters. Okay, it says how far is the base of each wire from the base of the pole. So let's take a look. We're looking for these 2 sides here. So we'll call this X and Y. Okay, so in this case here again, these are parts of these right angle triangles. So I don't need to use sine law or cosine law. So let's leave enough room to see that there. So here we'll start with X. So here I know H. I just found it, but I'm going to work with the 18 again because it's an exact value. So here now I'm going to use cosine, okay, because we have that cosine of 50 is equal to the adjacent over hypotenuse, so X over 18. So here X is just equal to 18 times cos 50. Let's do that quickly here. 18 times cos 50. So we've got 11.6. Oops, 11.6 meters. And then for the other triangle, again, I'm going to use cosine because the hypotenuse is the one that I know exactly. So here we have cosine of, in this case here, 80 degrees. Okay, and this should turn out to be a smaller value. So if this comes out to be bigger than x, chances are I made a mistake. So cosine of 80 is equal to y, the adjacent side, over 14, the hypotenuse side. So this is just equal to 14 times cos of 80, and that is 2.6. So not surprisingly, it is smaller. Okay, so we've solved all the numerical portions. Let's take a look at this question, which is interesting. So it says, could you solve this problem without using the sine law? Okay, so let's go back to what we had. Okay, let's forget those sides here. Could we find this angle, find this height, and then eventually these two sides without using the sine law? And the answer is yes, because if I look at this original triangle, okay, this original right angle triangle, I actually had an angle and a side length, so I had enough information to start solving. Problem is I wasn't going to be able to solve for the theta first. So that, in some ways, I guess the answer is no, because if I'm forced to go in this order, I can't find the theta directly. But what I can do is first find the height, which is the opposite side in this right angle triangle, and then use the fact that it's the opposite, and I know the hypotenuse side in this right-hand triangle, and I could have solved for theta. So could I solve for all of these things without using the sine law? Yes. Could I have done it in the order in which they gave it to me? And the answer is no. So it's not clear exactly what they mean. So I suppose there's a double answer here depending on what they mean by solving this problem. Okay, so again, just to recap here, I was not given a diagram. So step number one was to get a good diagram, to input all those things that I was given, realize that I was looking for this theta and that I have not had enough information to use the sine law. Secondly, was to realize that when I'm dealing with measurements that are within a right angle triangle, that I should be using traditional primary trig ratios. Okay, that's it for this one.